Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about systems of two equations. Y equals negative 3x plus 4. Let's make the other one in yellow. Y equals 3x minus 2. And we needed to solve this by graphing, okay? By graphing. So let's go make a graph here, okay? So let's go graph this. Well, let's graph the first one, our yellow equation. Y equals negative 3x plus 4. So we're going to start at 4, right? Our y-intercept is that 4 value. So we start at 4, put a point right there. Okay? We start at 4. Now we have a slope of negative 3. So we're going to go down 3 units, 1, 2, 3, over 1 unit. I'm going to do that again. Down 3 units, 1, 2, 3, over 1 unit. Okay? And for good measure, let's go 3 more down, 1, 2, 3, negative 5 over 1. And it's roughly right there. We see. Now, I'm not the best at this, so we'll see what happens, but we draw a line here. Connect it, and we move on through. Okay. So let's graph the other equation. Okay. So we have our first one now. It has a negative slope, and a y-intercept of 4. The other one has a y-intercept of negative 2. Negative 2. So we have a point right here at negative 2. And our slope is positive 3. So we're going to go up 3 units, 1, 2, 3, and we're going to go over 1, 1. Left over here, we share that point. Let's go again, another 3 units, 1, 2, 3, over 1, and there we go. That's good enough. So we're going to connect these dots, okay? Make a nice line. Continue down through, and there we have it. We have a point of intersection though. Okay, our point of intersection is right here, right in the middle. And that point is 1, 1. And that is our solution to this problem. Y equals x plus 2. And my second equation to be x equals negative 3. Well, the first thing I want to do is make a graph. So I'm going to make my little graph here. Okay. Okay, so we have our x and our y axes here labeled. All right, so let's go graph these. Well, our first one, we have a y-intercept of 2. So we have a y-intercept of 2 right here. Okay, and we have a slope of 1, which means our graph goes up 1 and over 1. So we have up 1 and over 1 right here, up 1 and over 1 right there. But also it can go down 1 to the left 1. Down 1, over 1, down 1, over 1. Okay. Move over, we have negative 3, negative 1 right here. That's negative 4, negative 2. And negative 5, negative 3. Okay. So we make our graph here. Now I'm trying to make it as straight as possible. And of course it's better when you use straight edge and graph paper, but we make do with what we have. Okay? The next equation though, we have here is x equals negative 3. When we have x equals a number, right, that's going to be a horizontal line at that number on the x-axis. So x equals negative 3. We look at negative 3 on the x-axis, we put a point, and our line is vertical, up and down, up and down. I don't think I said horizontal earlier, but it's vertical. Okay, so the point goes down here, so negative 3, negative 1, negative 3, negative 2, negative 3, negative 3. We're about negative 3, positive 1, and negative 3, positive 2. So when I draw this, there we go. We can see we have an intersection right here in the middle. Okay, right there in the middle, our intersection here at negative 3, which is kind of covered now, negative 1. So our final answer where these two lines intersect is negative 3, negative 1. X minus y equals 3. The second equation being 7x minus y equals a negative 3. But what we want to do is get both of these. I like to get both of them in y equals mx plus b form. So isolate y. So let's go quickly do that. Subtract an x of both sides, leaving off with a negative y equals a negative x plus 3. And divide both sides by a negative out front, so it gets y positive on the left, then becomes a positive x minus 3 on the right. So our first equation can be rewritten as y equals x minus 3. The second equation, all right, so the same thing. Let's get y by itself. We subtract the 7x of both sides, which gives us a negative y equals a negative 7x minus 3. Divide both sides by a negative y, or negative 1, and we have y equals a positive 7x plus 3. So here are the two equations that we will be graphing. So let's go make our graph. Let's graph the first one. We have y equals x minus 3. So minus 3 is our y-intercept. We're going to put a dot right there. Then we have a slope of 1, coefficient in front of x. Up 1 over 1, rise over 1, up 1 over 1, right here. Up 1 over 1, down 1 over 1, and down 1 over 1. Okay, so we have a nice little line right there. Okay, that represents our y equals x minus 3. The next one was y equals 7x plus 3. So we have a positive 3 as a y-intercept. Okay, plus 3 is our y-intercept, plus 3. We have a 7x. Well, 7x here. That means we can go up 7 over 1. Not really going to work, right? We're kind of off our graph. So let's go opposite, down 7 to the left 1. Down 7 units, 1, 2, 3, 4, 5, 6, 7. At negative 4, over 1, right here at negative 1. And there we have it. We actually see our intersection there, so I'm doing my best to draw that line, long distance without straight edge, but I manage. There we go. And so we have an intersection there. Our intersection is at negative 1 comma negative 4. And that's where these two equations meet. And that's the only solution where they're both true. 4x plus y equals 2. So my second equation is x minus y equals 3. All right. Well, first thing I want to do is I like to get both of these into y equals mx plus b form. So we got y by itself. Subtract the 4x on both sides, and y equals a negative 4x plus 2. And there we have it. Pretty simple for that. The other one, I want to get y by itself. Subtract an x to both sides. I have a negative y equals a negative x plus 3. Divide by negative 1 to both sides. Y is isolated now. We have a positive x minus 3. Okay? So we now have our two equations. We need to graph them. So let's go make a little graph. So we have our graph. Let's go graph the first one. All right, the first one being in green, y equals negative 4x plus 2. I start with my y-intercept at 2, right here, and negative 4 is my slope. Down 4 units, 1, 2, 3, 4, over 1, and 1, 2, 3 is going to be off the page over 1. So leave it as it is. Okay, so we have our graph right there. Okay, and it's going to continue down. So over here. Okay, it's going to go up. Left. There we go. All right. The other equation we have, y equals x minus 3. So we start with the negative 3, okay? And we have a slope of 1, the coefficient in front of x, up 1 over 1, up 1 over 1. And we can see we already have the intersection there, up 1 over 1, up 1 over 1. And then down 1 to the left 1 for good measure. So we connect these dots, make our line here. And there we have our solution, where these two lines intersected, which is at negative 2, negative 2, comma. I was going to the y-axis first, that's incorrect. I'm going to go to the x value, 1, comma, negative 2. Common mistake there, be careful. So our final answer is just 1, comma, negative 2. y equals 4x minus 9, and y equals x minus 3. Well, when doing substitution, we want to find which one of these, or if we can easily get a variable by itself, which we can. All right, it's already given to us. Both equations have y written by itself. So, since y is equal to 4x minus 9, I'm going to take that 4x minus 9 and substitute it in for the other y in the other equation. Okay, since y can equal it, I can substitute that in, hence the method, right? So we have 4x minus 9 here instead of that y equals x minus 3, which was written there. Now I'm going to solve for x. I'm going to subtract an x to both sides. I'm going to add a 9 to both sides. 4x minus x is a 3x, and negative 3 plus 9 is a positive 6. From there, I want to get x by itself. I'm going to divide both sides by 3, leaving me x equals a positive 2. We have one of our variables that we found the answer of, right? 2. We need to find the other one. So I need to plug x equals 2, or 2 for x, into one of these equations. I'm going to pick the easier one. I think it's the second equation. So I have my y equals x minus 3, and I'm going to substitute that 2 in for the x. Y equals 2 minus 3. Okay? 2 minus 3 is a negative 1, so y equals a negative 1. And so our final answer, we can write, all right, as a coordinate point, we have our x and y value, we write that as a coordinate point here, 2, comma, negative 1. That's it. 4x plus 2y equals 10. In my second equation, x minus y is equal to 13. Well, not one of my variables is already isolated, but I know on the second equation I can get x by itself very quickly. I just have to add a y to both sides, so I'm going to do that. So I can rewrite the second equation to be really adding a y to both sides, right? And x equals 13 plus y, which is y plus 13. Okay, pretty simple. So with that being said, okay, so again, this is still equation number 2. Okay, equation number 2. I'm going to take that x equals y plus 13, I'm going to plug it in for the x in this equation. So we have 4 times, the second equation comes down, 4 times, well, instead of x, I'm going to put y plus 13, right there, plus 2y equals 10. And from here, I'm trying to solve, okay? I'm going to solve for y. Well, I had to distribute the 4 across, right? 4 to the y, so 4 to the y is easy, 4y. And 4 to the 13 is what? 4 times 10 is 40 plus 4 times 2 is 12, 52. We have 52 there, and then we add a 2y, and that's equal to 10. All right, so let's go subtract the 52 to both sides. Combine the 4y and 2y. Well, 4y plus 2y is a 6y. And when I subtract 52 to both sides, it's 10 minus 52, which is a negative 42. Okay? All right. Now, from here, we want to get y by itself, so I'm going to divide y, divide 6 to both sides here. 6 to both sides. Okay, divided by 6 to both sides, giving me y by itself, which I'll write right there, is a negative, well, 6 goes into 42, 7 times. Okay? So we have a negative 7 right there. All right? Negative 7. So we have y equals negative 7. I need to plug it back into one of my other equations to find the x value. Now, luckily for me, the second equation looks pretty easy. So I'm going to rewrite the second equation. X minus y equals 13. And we'll plug that 7 in for the y. Okay, and the negative 7 for the y. So we have x minus a negative 7 equals 13, which is really x plus 7 equals 13. So now, because we haven't subtracted a negative as possible, I'm going to subtract the 7 to both sides, leaving me x equal to be 13 minus 7, which is a positive 6. So our x value is positive 6, and y value is negative 7. Together, they come to the coordinate point, which is our final answer, 6, comma, negative 7. There we have it. Y equals negative 5, and 5x plus 4y equals negative 20. Well, what I like about this already is I already have a variable by itself. y is equal to -5. So it makes it pretty easy to plug that 5 in for the second y right here, right? Or the second equation is y. So I'm going to plug this little 5 in for that y. So we have 5x plus 4 times a -5 equals a -20. Now I'm just trying to get x by itself. 5 times -5 is a positive, or -20. 5x plus a -20 equals a -20. I'm going to add a 20 to both sides, leaving me with 5x equals -20 plus 20, 0. So we have 0 right there. So I have 5x equals 0, divide both sides by 5. And I have x equals 0 divided by 5, which is 0, right? So our x value here is just 0. Now we need to find the y value. Well, this one's actually pretty good if you can see it. We already given that y is equal to -5, and so that's what it is. But let's go plug it into the second equation just to be sure. Okay, so my second equation, 5x plus 4y equals -20. Let's plug that 0 in for x. 5 times 0 plus 4y equals -20. 5 times 0 is 0. So we have 4y equals -20. Divide both sides by 4, and y equals a -5, right? -20 divided by 4 is a -5. So we could have just grabbed it from the beginning, the first equation, like I said. But it's all good if you need to substitute it back in to be double sure. So we can write this as a coordinate point, 0, -5, and that would be our final answer. X plus 7y equals 0, and 2x minus 8y equals 22. Well, what I want to do is isolate one of the variables. I think the first equation is the easiest way to do that. That x, right, we have x plus 7y is easy to get, and really x by itself. So I'm going to rewrite this kind of right here. Let's just bring this down a little bit here. So I'm going to rewrite it, put it below, and I'm going to subtract the 7y to both sides. So that can be rewritten as x equals really a -7y. You can see that I'm subtracting 7y to both sides. From there, right, it's kind of a little double substitution. We can see x is a -7y. So when I rewrite the second equation, I have 2 times, I'm going to put a -7y in for x. Okay, but not equal to. And so I'm going to subtract the -8y of the second equation equals 22. You can see that one came down from here. Okay, so let's go simplify now and get y by itself. 2 times -7y is a -14y. We have -8y right here, and that's equal to 22. From there, -14y minus 8y, we need to combine those together, okay, and we have a -22. -22y equals a 22. From there, we get y by itself, divide both sides by -22. And I'm left with y equals 22 divided by -22, which is a -1. Okay, so now we have our y value, we need to find our x value. So I'm going to go with the first equation. I think that looks a little easier. We have x plus 7y equals 0. I'm going to plug a -1 in for the y. X equals, how is that? Equals, now it's plus sign. So plus sign right here, plus sign. 7 times a -1 equals 0. 7 times a -1 is a -7. So we have x plus a -7 right here equals 0. We add a 7 to both sides to eliminate that -7. And we're left with x by itself equals a +7. So now we have an x value and a y value, right? We can write that as our coordinate point for our final answer, which is just 7, -1. And there we have it. Our final answer, our solution to the system's equation using substitution is 7, -1. 6x plus 8y equals -22, and y equals -5. Okay. Well, we already have y isolated. Okay, so I want to plug that isolated y, which is equal to -5, into my first equation. So if I rewrite my first equation, 6x plus 8, and instead of y, I'm going to put a -5 there. Right? This little -5 goes right in, equals that -22. Okay. From there, I need to simplify, try to get x by itself. So 8 times -5 is a negative 40. So we have 6x plus a negative 40 equals a negative 22. I'm going to add a 40 to both sides here, giving me 6x by itself. And negative 22 minus 40 is a 18, positive 18. I'm going to divide by 6 to both sides, giving me x by itself, and 18 divided by 6 is 3. So we have x equals 3 right there. So now we need to find the y value. Now, lucky for us, y was already given from the beginning. Y is negative 5. But if we must, okay, let's get let's go plug into our first equation just to see. So it's 6x plus 8y equals negative 22. 3 goes in for x there. 6 times 3, right, plus 8y equals a negative 22. 6 times 3 is 18, and now we add the 8y to it equals negative 22. We subtract from 18 to both sides to get y by itself. 8y equals negative 22 minus 18, which is a negative 40. And divided by 8 to both sides, y is by itself, negative 40 divided by 8, negative 5. Same answer we had here, okay, just got it a different way. So we have our 2 points. We can make our x and y value. We have our coordinate point here of 3, negative 5. And that is our final answer. Negative 7x plus 2y equals 18. And 6x plus 6y equals 0. Well, what I want to do is get one of these variables isolated by itself. And I find it easier actually with the second equation. So watch this. I'm going to subtract a 6y to both sides. That leaves me with 6x equals a negative 6y. Be careful with this. Take your time. Divided by 6 to both sides gives me x by itself. And negative 6 divided by 6 is a negative 1. So we have a negative y here. And this is where it becomes tricky. We know that x is equal to a negative y. Okay? So we're going to go to our first equation and we're going to plug that in. So instead of x, we're going to put a negative y in. Okay? So our first equation, let's go rewrite it right here. I'm going to bring it down now. I took a lot of space, but it's okay. Negative 7, and instead of x, I'm putting a negative y in. That's a 7. Negative y in plus 2y equals 18. All right, negative 7 times a negative y is positive 7y, right? Negative times a negative is positive, plus 2y equals 18. 7 plus 2y is 9y. I divide by 9 to both sides. That fits on the page there. And so 9y divided by 9 to both sides, we have y equals a positive 2. Right, just barely fit it in there. Okay, so y equals a positive 2, 18 divided by 9. So now I'm going to plug that into my other equation, or actually either one really doesn't matter, to try to get my x value. So let's go pick our second equation. Let's go with that. Let's see what happens. So we have 6x plus 6y equals 0. Now you might be able to see here if y is 2, plug it in, we have our x value, so it should be a negative 2, but let's go see what happens. So let's plug that y equals 2 in. Okay, we have 6x plus 6 times a 2 equals 0. 6 times 2 is 12, so we have 6x plus 12 equals 0. Subtract the 12 to both sides. 6x equals a negative 12, divide by 6 to both sides, gives me x by itself is equal to negative 12 divided by 6 and negative 2, which makes sense, right? X is equal to a negative y. If x is negative 2, and negative, and then that's equal to the negative y, the double negative, right? Because in 2, or not double negative, but y is 2, the negative's out front, equals a negative 2. Either way, our coordinate point is negative 2, comma, positive 2. When we combine them together, and that is our final answer. 7x plus 2y equals a negative 19, and negative x plus 2y equals 21. Well, from there, what I want to do is I want to get a variable by itself. I find that's easier in the second equation. So I'm going to subtract the 2y and try to get x by itself. Subtract 2y to both sides. Pretty simple. I have negative x now equals negative 2y plus 21. Divide by negative 1 to both sides, right, or multiply it to both sides, and I have x is equal to, well, negative distributes, right? So negative times a negative is a positive, so we have positive 2y, and then 21 would be a negative 21 minus 21 right there. So now I have x equals 2y minus 21. Well, x is isolated, so now I'm going to put that into my first equation. So we have 7 times, and instead of x, I'm going to put this 2y minus 21. 2y minus 21 in. Alright, so that's going in right there. Plus 2y equals a negative 19. Well, now I got to simplify this bad boy. Okay? 7 times 2y is a 14y, and it's equal to, subtracting there. And then when we distribute the 7 again to the minus 21, oh, what is that? 147, negative 147, 7 times 21, yeah, negative 147 plus 2y equals negative 19. I'm going to add a 147 to both sides. I'm going to combine the 14y, 2y to be a 16y equals negative 19 plus 147. I don't know why I'm using a calculator. It's stupid. All right, don't do that, Sean. As a positive 128 for the essence of time. For the next part, I'm going to divide both sides by 16. So let's go finish that right up here. Okay. We have y equal to 128 divided by 16. And so y is equal to, and that 128 divided by 16, which I had there, is an 8. Okay? Is an 8. So we have y is equal to an 8. Well, now we need to find what x is equal to. So I'm going to plug that y and 8 into one of my equations. I'm going to pick the second equation. So we have a negative x plus 2y equals 21. Let's plug that 8 in for the y. Negative x plus 2 times 8 is equal to 21. 2 times 8 is a 16, so we have negative x plus 16 equals 21. Subtract the 16 to both sides, and we have negative x equals 21 minus 16, which is a positive 5. Positive 5, divide both sides by negative 1, and we have x equals a negative 5. So we have our x, our y value, coordinate point can be written together as negative 5, 8, and there we have it. Our final answer being negative 5, 8. 3x minus 5y equals a 17. And my second equation, just y equals a negative 7. Well, lucky for me, we're already given y by itself. So what I'm going to do is take the first equation, 3x minus 5, and instead of a y, I'm going to plug in that negative 7 equals 17. So I'm going to bring down that first equation right there. Okay. Well, pretty simple. 5. All right, let's distribute that negative 5 or multiply it out. So 3x times negative 5 times a negative 7 is a positive 35 equals 17. I'll subtract a 35 to both sides. Let's get x by itself. And we have 3x equals 17 minus a 35. Oh, save time. 17 minus 35. So right here, negative 18. So we have a negative 18 like that. Divided by 3 to both sides gives me x by itself. Negative 18 divided by 3 is a negative 6. So we have an x value of negative 6. Now, what's nice is we were already told that y is equal to negative 7 from the beginning. So we can combine the knowledge of these two parts together to get our final answer, which is just a coordinate point of negative 6, negative 7. And there we go. Final answer is pretty simple here, is negative 6, negative 7. Negative 7x plus 4y equals 24. And my second equation is 4x minus 4y equals a 0. Well, what I want to do is I want to get one of these variables by itself. Second equation looks easier. So I'm going to add a 4y to both sides. That leaves me with 4x equals 0 plus 4y, which is 4y. Divided by 4 to both sides, and I have x equals 4y divided by 4, which is just y. So I have x equals y right there. Pretty nice fact, but be careful with this. A lot of students will mess that up. So let's go rewrite my first equation here, okay? First equation comes back down. Negative 7, and instead of, I really can pick which one I want, but instead of x, I'm going to put a y there. So Substituting instead of x, the y, plus 4y equals a 24. Now I'm going to solve for y. Negative 7 times y is negative 7y, plus 4y equals 24. Negative 7y plus 4y is negative 3y equals 24. If I divide by 3 to both sides, I have a y equals, well, a negative divided by negative 3, excuse me. 24 divided by negative 3 is a negative 8. So we have y equals negative 8. I need to plug that into another one of my equations. Now we can look right here and say, hey, x equals y, so x has to be negative 8, right? Let's just amuse ourselves. Let's pick the second equation here. So we have 4x minus 4y equals 0. Let's plug that negative 8 in, okay? Well, we have 4x minus 4 times negative 8 equals 0. 4 times negative 8, or negative 4 times a negative 8, okay, is a positive 32. 0. Subtract the 32 to both sides. Pretty redundant here. 4x equals a negative 32. Divided by 4 to both sides. We get x equals a negative 8. What we kind of knew right there. Either way, our final answer we can write as a coordinate point. Negative 8, comma, negative 8, our x and y value. And there we have it. Our final answer. 4x minus y equals 20. And negative 2x minus 2y equals 10. Well, from there, what I want to do is I want to get a variable isolated. I think that's easier in my first equation. So I'm going to rewrite my first equation here, but I'm going to subtract a 4x on both sides. So I have negative y equals negative 4x plus 20. Okay, so hopefully you can see that I subtracted a 4x on both sides. From there, I divided by negative 1 to both sides to get y by itself to be, well, distribute the negative 1, positive 4x minus 20. So I have y equals 4x minus 20, and I'm going to plug that in to the y of my second equation. So negative, so this one's coming down now, negative 2x minus 2 times, which my y is, I'm plugging right here, right? 4x minus 20, and that's equal to 10. From there, I need to distribute the negative 2 across. So we have negative 2x right here. Negative 2 times a 4x is a negative 8x. And negative 2 times a negative 20 is a positive 40 equals 10. So let's combine. Negative 2x minus 8x is a negative 10x. And if I subtract a 40 to both sides, okay, I'm left with that 10 minus 40 is negative 30. Divided by negative 10 to both sides. And I have x equals a positive 3. So we have x equaling a positive 3 right here. I have to pick one of my other equations to substitute it back in. Let's go to the first equation. So 4x minus y equals 20. I'm going to plug 3 in for the x. Okay? 4 times 3 minus y equals 20. 4 times 3 is 12. Minus y equals 20. I'm going to subtract 12 to both sides to get y by itself. So negative y here. 20 minus 12 is a positive 8. Divided by negative y, not a negative 8. Negative y right there to both sides. And I have y, or sorry, negative 1. A y. What am I doing? Ugh. And of course it doesn't erase well. Divide both sides by a negative 1 to get rid of that negative. I have y equals 8 divided by negative 1, which is a negative 8. So our final answer here, combining these two to be a coordinate point, is 3 comma negative 8. X minus 6y equals a negative 20, and negative 16x plus 7y equals 30. When solving with an elimination, what I want to try to do is see if I can maybe add or subtract the top and bottom equation to eliminate essentially one of the variables. And so I'm kind of looking for opposites in a sense here. And I see 8x and negative 16x. And I know that if I multiply 8x by 2, I'd get a positive 16x. And I could add that to negative 16x, and that becomes 0. That's the ultimate goal there. So what I'm going to do is I'm going to take this first top equation and I'm going to multiply the whole thing by 2. The whole thing by 2. So let me put a little segue here. Transition over. So I'll multiply that whole thing by 2. So that becomes, well, 2 times 8x is 16x. And 2 times a minus 6y is a minus 12y. And don't forget the negative 20. 2 times negative 20 is negative 40. If I did this right, I should just be able to transfer the second equation, negative 16x plus 7y equals 30. Now what I'm going to do is I'm going to add them. Add these two equations straight up and down, okay? 16x and a negative 16x, when I add them together, is a 0. Fantastic. That's what I want. Negative 12y and a positive 7y is a negative 5y. And negative 40 and positive 30 is a negative 10. So at this point, I have an equation with just one variable. So we just need to solve for that variable. 0, don't really care about it. It's gone. I'm going to divide both sides by negative 5. This gets me y by itself. Negative 10 divided by negative 5 is a positive 2. So we have y to be a positive 2. So now what we're going to do is plug that back into one of my equations and simplify. I'm going to pick the first one again. First one. So I'm going to take that 8x. Alright, without the multiply by 2. So the 8x minus 6y equals negative 20. And I'm going to take this y being 2 and plug it in. So I have 8x, plug it in for y. 8x minus 6 times 2 equals negative 20. 6 times 2 is 12. 8x minus 12 here equals negative 20. Add a 12 to both sides. We have 8x equals negative 20 plus 12, which is a negative 8. Divide by 8 to both sides. And x equals good old negative 8 divided by 8 is a negative 1. So we have our x and y value. We can combine them together to be a coordinate point, which is negative 1, comma 2. And there we have it. Final answer. 6x minus 12y equals 24. And negative x minus 6y equals a positive 4. Well, what I want to do with elimination, I'm going to see, can I multiply one of these equations or both of them to get them up, like one of the variables opposite of the other one. So the way I'm looking at this and thinking about it, I'm looking at the negative 12 and the negative 6. I know if I multiply 6 by 2, I can get 12. And if I multiply the negative 6 by negative 2, I'm going to get that positive 12. That's going to be opposite of the negative 12 above it. So what I'm going to do is I'm going to rewrite the first equation, 6x minus 12y equals 24. But the second equation, I'm going to multiply by negative 2, and that's the whole equation. So in doing so, negative 2 times negative x is a positive 2x. Negative 2 times a negative 6y is a positive 6y. And negative 2 times 4 is a negative 8. From there, I'm going to add these two equations. I'm going to add down. So let's bring them down here. Oh, negative 2 times negative 6y is a positive 12y. That was the whole point. Double check that. It should eliminate. Right? I did that on purpose to make it a learning opportunity. All right. So to add these two straight down, 6x plus 2x is a 8x. Negative 12y plus a positive 12y is a 0, which it should. If it doesn't, you messed up, and I almost did. Okay. 24 and a negative 8 come out to be a positive 16. From here, we don't really care about the 0. We can just eliminate that. Pun intended. And I'm going to divide by 8 to both sides to get x by itself. That gives me x equals 16 divided by 8, which is 2. So now that we have our x value, we need to plug that back into one of our equations to get our y value. I find the second equation looking a little bit easier, or nicer. So I'm going to take that negative x minus 6y equals 4, and I'm going to plug that x equals 2, or 2 in for x. So we have negative 2 minus 6y equals 4. Okay. Well, negative 2, really there. Okay, we can add a 2 to both sides. This gives me negative 6y by itself equals a positive 6. Okay, divided by negative 6 to both sides. We have y equals 6 divided by negative 6 is a negative 1. So we have our x value and our y value. They can come together to be a coordinate point, which is negative 1, comma 2. Here we have it, our final answer. Negative 8x minus 10y equals a positive 24. And in the second equation, it would be 6x plus 5y equals 2. Well, I can easily identify that 2 times 5 is my 10. And since I have a negative 10 at the top, that's all we need to do. So all I'm going to take now is my second equation and multiply it all by a positive 2. So let's rewrite the first equation, negative 8x minus 10y, and that's equal to 24. The second equation, I'll multiply the whole thing by 2. 2 times 6x is a 12x, and 2 times 5y is a 10y. And 2 times 2 is a 4. From there, I'm going to add these two equations together, top to bottom. Negative 8x plus a 12x is a positive 4x. And negative 10y plus a positive 10y should eliminate, that was the whole point, is 0. 24 plus 4 is a 28. So now we want to eliminate, or not eliminate, or we can eliminate the 0, we don't really need that. I'm going to get x by itself. So I have to divide by 4 to both sides. That leaves me with x by itself. And 4 goes into 28 7 times. So x is just 7. From there, I need to plug that back into one of my equations. Now, I find the, the second equation easier. So I'm going to rewrite that second equation here. 6x plus 5y equals 2. And I'll plug that 7 in for x. Okay? So 7 goes in for x right there. And what I want to do is 6 times 7 right here. Substitute that in. 5y equals 2. And I'm going to solve for y. 6 times 7, 42. Plus 5y equals 2. Now I'm going to subtract the 42 to both sides. Leaves me with 5y equals, well, that's a negative 42 minus 42. Divided by 5. And I have y that's written here by itself. Negative 40 divided by 5 is a negative 8. And there we have it. We have our y value, we have our x value. Together they can make a coordinate point, which is 7, comma, negative 8. And there we go. Our final answer. Negative 24 minus 8x equals a 12y. And then I have 1 plus 5 ninths y equals a negative 7 18ths x. Well, first thing I'm going to do here is I'm going to multiply the second equation by 18. And the reason why I'm doing that just right from the beginning is I see something with a fraction, something without a fraction, and I find it easier to deal with everything without fractions, and that's my personal preference here. So I'm going to multiply 18 across, and the reason why I did that was the largest denominator here, and this one, really 18 and the 9 will cancel out, give me just a 2. That seems pretty easy to do. So we have a negative 24 minus 8x equals 12y, and then we have 18 multiplied across. 18 times 1 is 18. Plus, well, 18 times the 9, or divided by the 9, gives me a 2. 2 times 5 is 10, so we have 10y here. And then 18 eliminates, we just have a negative 7x right there. Well, what I'm going to do now is I'm going to rewrite this, okay, one more time, rewrite it to have all the variables on the same side. So I'm going to leave the numbers on the left-hand side, and it's kind of really add the 8x and subtract the 10y. So in the numerator, we have a negative 24 still. That's going to be equal to a positive 8x plus 12y. And the denominator, just leave the 18 there, but I'm going to subtract 10y on both sides, leaving me with a negative 7x minus 10y. Okay. So now this becomes a little tricky here. We have negative 24 equals 8x plus 12y, and 18 times a negative 7x minus 10y. And so really what we want to do now is how can we get all of this, all of them to have the same, to essentially eliminate one of the variables. What can I multiply one by the other to have really the same variable? Okay. And there's a few ways to go about it. What I'm going to do actually, because I'm just going to try it this way, is I'm going to multiply the whole. So what you can do, if I want to eliminate, let's say, the y, I'm going to multiply the whole numerator by the coefficient in front of the y. So in this case, I was multiply it by 10. I wasn't really pick a positive 10 because there's a negative down here. And if you do the whole thing multiplied by a positive 12 in the denominator, what that's going to do is 12 times 10 is the same thing as 10 times 12. But this one's going to be negative, and so when I multiply it all out, it's going to eliminate that variable. So let's kind of rewrite that right here. Okay, and let's go multiply that out. It should be pretty easy to do with the 10. So we have negative 240 equals 80x plus 120y. And in the denominator, I don't have these memorized, so 18 times 12 is 216. So we go positive 216 right here equals negative 7 times 12, which is a negative 84. That's x plus, or minus in a sense here, minus 120y. And what that allows me to do now is I can eliminate these two, top to bottom. Okay. Negative 240 and positive 216, because I'm really doing that in my head. Negative 240 plus 216 is a negative 24. I should have done that in my head quickly, but oh well. Okay. 80x plus, minus 84x is a minus 4x. And, like it should have happened, 120 and a negative 120 is a 0. So you have plus 0 right here. After that, I have to divide by a negative 4 to both sides. And that leaves me with the x by itself here on the right. And negative 24 divided by negative 4 is a positive 6. So we have x to equal 6. Go write that as x first. So now, pretty easy, we just need to substitute that back in to our one of our equations. And personally, I'm going to pick the first equation. Okay. So let's go with that. We have our first equation. We'll rewrite right here. Negative 24 minus 8x equals 12y. And we're going to try to solve for y. So I'm going to plug 6 in for x right there. 6 in for x. Okay. So we have a negative 24. Okay. Minus 8 times 6 equals 12y. 8 times 6 is that 48. So we have negative 24 minus 48 equals 12y. Okay, so now we combine negative 24 and negative 28 comes out to be, let's go add that together. 4, carry the 1 over 2, so the negative 2 there. Carry the 1 to 6, 72. So negative 72 equals 12y. Alright, so I need to divide by 12 to both sides. And that gives me a y by itself here is equal to negative 72 divided by 12. That comes out to be a negative 6. Alright, so we have x is a positive 6, x is a negative 6, or y is a negative 6. I should flip that. Either way, it doesn't matter. Our final answer is written like this. X first, 6. Y is a negative 6, and that is our coordinate point and our final answer. Negative 4y minus 11x equals a 36, and 20 equals a negative 10x minus 10y. Okay. Well, what I want to do is I want to get basically these equations to look the same. Essentially have all the x's on one side and y's on one side and the numbers on the other side. That's the way I like to see it for elimination. So let's segue over here and let's go rewrite it. Now luckily for us, what I can do here is, it really doesn't matter in a sense, but you can, the numerator I'm going to leave out on the top equation, negative 4y minus 11x equals 36. Not 6, but 36. The second one, you essentially can just flip it, but what I'll do is just essentially say, I'm going to add the 10x to both sides and 10y to both sides and just subtract the 20. So we have a positive 10y here, positive 10y here, plus 10x, equals a negative 20. And it really didn't matter. You could have just kind of flipped it because like I could multiply the whole thing by negative 1 and really get that. But I did this on purpose so then I'd have opposite variables for my, or the top would be negative, bottom would be positive when I do my next step. So what I want to do now is see, okay, what can I do to multiply the numerator and or the denominator? The top and the bottom, they're not numerators and denominators. That's just, yeah. Anyway, so multiply that out. So what I'm going to do is, I'm going to multiply the whole top equation by 10. That's right here. And the bottom equation by 4. And that will ensure, because 10 times negative 4, or 10 times 4 is the same thing as 4 times 10, ensure that the y's will be eliminated. 10 times negative 4y is a negative 40y. And 10 times negative 11 is a negative 110x. And that equals 360. Okay? The bottom, multiply that whole thing by 4. 4 times 10y is a 40y. 4 times 10x is a 40x. And 4 times negative 20 is a negative 80. So what I'm going to do now is add these two equations. They should eliminate the y, which they do. Negative 40y plus positive 40y is 0. So 0 right there. Plus, now we have negative 110x plus a positive 40x comes out to be, oh, what is that? Negative 70x. Now we have 360 minus 80 is a negative or positive 280. Positive 280. So now we divide both sides by negative 70. And that should give me x by itself here. And 280 divided by a negative 70, I believe it's just a negative 4. Okay. So we have x equal to be a negative 4 here, which is great. So now what we're going to do is plug that into one of my equations and solve for the variable y. Okay. Let's just pick the let's go pick the second equation. So I'm going to rewrite that down here. 20 equals negative 10x minus 10y. And I'm going to plug in this knowledge that x is 4. So we have 20 equals negative 10 times a negative 4 minus 10y. Simplify that. Negative 10 times a negative 4 is a positive 40. So we have 20 equals positive 40 minus 10y. And then I'm going to subtract a 40 to both sides, leaving me with 20 minus 40 to be a negative 20 equals a negative 10y. Divided by negative 10 to both sides. And really y comes by itself is a positive 2. So now we have x is a negative 4, y is a positive 2. I can write that as a coordinate point here as negative 4, 2. And that would be my final answer. Negative 9 plus 5y equals a negative 4x. And the second one is a negative 11x equals negative 20 plus 9y. Well, the first thing I want to do is I'm going to get all my numbers to one side, all my variables to the other. So let's do that by, I'm going to the numerator, let's go bring all the variables to the left, the straight numbers to the right. So the numerator becomes, I'm going to add a 4x to both sides, so we have positive 4x plus 5y. And that's going to be equal to, if I add a 9 to the other side, a positive 9. The second equation, do the same thing. And so then subtract the 9y to both sides. So we have a negative 11x minus 9y. And that's going to be equal to a negative 20. So what I want to do here is I'm going to have to multiply both equations by a value to eliminate one of the variables. Okay, and so we can kind of quickly do that. Depends on which one you want to do. It really doesn't matter if we want to eliminate the x or the y. And so let's go with the eliminate the y. So I'm going to multiply the top equation all by the coefficient in front of right here. This y is a 9, so multiply the top one by 9 and the bottom one by 5. And what that does will help eliminate this variable. Okay, so we multiply across. All right, you can see here. 9 times a 4x is a 36x. And then 9 times 5y is a 45. So the 45y here plus 45y. And 9 times 9 is 81. So do the same thing with the 5. Multiply the 5 across. 5 times negative 11 is a negative 55x. And 5 times a negative 9y is a negative 45y. 5 times negative 20 is a negative 100. So now I'm going to add these two equations together. Okay. Hopefully, we should eliminate the y variable. Okay. So adding the x's together, 36 minus 55. Oh, minus 55 comes out to be a negative 19. We have negative 19x. The y's will cancel. 45y and negative 45y will be a 0. And 81 and negative 100 come out to be a, is that 19 again? Yes, that's a negative 19. Okay. To get x by itself, I'm going to divide by negative 19 to both sides. I don't really care about the 0. I'm sort of left x here by itself equals negative 19 divided by negative 19 is a positive 1. So we have a positive 1 right there, and that is our x value. But we need to find our y value. So what we're going to do is take one of the equations and plug x to be 1 and solve for y. So let's go with our second equation here. Negative 11x equals a negative 20 plus 9y. And let's go plug in 1 for x. Well, 1 goes in for x right there. We have negative 11 times 1 equals negative 20 plus 9y. Negative 11 times 1 is just negative 11 equals negative 20 plus 9y. I'm going to add a 20 to both sides. That leaves me with a positive 9 equals 9y. I'm going to divide by 9 to both sides, and y is just equal to, well, 9 divided by 9 is just 1. So we have x to be 1, y to be 1. Our final answer as a coordinate point is just 1, comma, 1. And there we have it. 0 equals negative 2y plus 10 minus 6x. Second equation is 14 equals, or 14 minus 22y equals 18x. Well, what I'm going to do is I'm going to rewrite this to have all the variables on one side, all the numbers on the other. Okay, so for the numbers on the left, variables on the right. So when we rewrite this, I'm going to subtract the 10 to both sides, give me a negative 10 on the left equals negative 2y minus 6x on the right. This one here, I'm just going to add a 22y to the right, giving me the 14 left on the left, and then we have a positive 22y and a positive 18x on the right. So now at this point, I'm going to look at it and say, okay, can I multiply one of these equations or both of them by a number to cause one of the variables to get eliminated, looking at their coefficients? And I know that 6 goes into 18 3 times, so if I multiply the top number, or top equation, by 3, we can eliminate the x variable, especially because there's a negative right there on 6. So I multiply the top one by 3 to all parts. So 3 times negative 10 is negative 30 equals 3 times negative 2y is a negative 6y, and 3 times a minus 6x is a minus 18x. I want to bring over the 14 equals 22y plus 18x, so 14 equals 22y plus 18x, and that is unchanged. We add these two equations together, okay, top down. Okay, so when we add them together, negative 30 plus a positive 14 is a negative 16. Negative 6y plus 22y is a 16y. And then negative 18 plus 18 is 0. So we have 0 right there. Okay. Well, now what we're going to do is I'm going to divide both sides by 16 to get y by itself. We don't really care about that plus 0 anymore. Okay. On the right, we have y by itself, and negative 16 divided by a positive 16 is a negative 1. And for good measure, we can write y first. Y equals a negative 1. So now that we have our y value, we need to plug it back into one of our equations to get our x value. Okay? And so the way we're going to do that, the way I see that we can do that, is I'm going to go look at, let's just go with this one, the second equation. So I'm going to take that 14 minus 22y equals 18x, and I'm going to plug in negative 1 for y. So in doing so, I have 14 minus 22 times a negative 1 equals 18x. 22 times, well, it's a negative 22 really, times a negative 1 is a positive 22. So we have 14 plus 22 equals 18x. 14 plus 22 is 36 equals 18x. I'm going to divide by 18 to both sides, leaving me with x by itself, and 36 divided by 18 is just 2. Now if we want to write x first, we can. It's x equals 2. So now we have our x and our y value. We can write this as a final answer in the coordinate point form of 2, 1. Our x value first, then our y. And there we have it. Our final answer is just 2, 1. So let's recap. We're given our two equations, 0 equals negative 2y plus 10 minus 6x, and 14 minus 22y equals 18x. From there, I rearranged it to have the numbers on the left and then the variables on the right. Then I looked at it and said, okay, I know I can multiply negative 6 times 3 to get my 18, so I'm going to multiply the top equation all by 3. After I did that, I added the two equations together, which eliminated the variable x. That was the whole point. Hence elimination. I then divided by 16 on both sides, giving me y by itself to be a negative 1. I plugged that into my second equation. It could have been any one. I chose my second equation. And I plugged that in for y and simplified and solved for x. And in doing so, I got x to be 2. Now I had x is 2, y is negative 1. I can write that as a coordinate point. And our final answer using of the system of equations using elimination is 2, 1, or negative 1. Negative 1. Negative 16y equals 22 plus 6x. Second equation, negative 11y minus 4x equals 15. Well, first thing I'm going to do is I'm going to rearrange this to have all my variables on the left and the number on the right. So really the top equation needs to change. I'm going to subtract the 6x on both sides. So negative 16y here minus 6x now equals positive 22. And in the second equation, I just bring it over. Negative 11y minus 4x equals 15. Well, what I want to do now is see if I can eliminate one of the variables. And I'm thinking that x is going to be the easiest. If I multiply 4 by 3 and 6 by 2, both of them will equal 12. Now what's tricky though is one of them I'm going to have to make negative. Okay? So let's go make the bottom one negative. So I'm going to multiply the bottom one by a negative 3 and the top one by a positive 2. Okay? This will allow me to have a positive 12x here, and this one will be a negative 12x, and so when I add them together, they will eliminate. So when we do that, we'll strip that across. 2 times negative 16 is a negative 32y, and 2 times a negative 6x is a negative 12x, and that's equal to a positive 44, 2 times 22. Same thing for negative 3, multiply that across. Negative 3 times 11y is a positive 33y. And positive, negative 3 times a negative 4 is a positive 12x. And 15 times a negative 3 is a negative 45. When I add these two equations together, right, negative 32y plus 33y is just 1y. Negative 12x plus 12x is 0. And negative 44 plus a negative 45 is a negative 1. We don't really need the 0, so really, right here we got our y value to be negative 1. So now what we're going to do is plug that into one of our other equations and simplify. So let's go pick the second equation. Negative 11y minus 4x equals 15. And again, it doesn't matter which equation we choose. I just chose the second one. Negative 1 goes in for y, so we have negative 11 times a negative 1 minus 4x equals 15. Negative 11 times a negative 1 is a positive 11, so we have positive 11 minus 4x equals 15. I'm going to subtract 11 on both sides, giving me negative 4x equals a negative 4. From there, I'm going to divide by a negative 4 to both sides, giving me x to be a positive 1. A negative, sorry, this is a positive 4. Whoops, I made that up. 11 minus 15 minus 11 is positive 4. And then we divide by negative 4, I have a negative 1. It's messed up there. Okay? So we have x is -1, y is a -1 as well. And so our coordinate point final answer is just -1, comma, -1. All ones are weird. All right. But there we have it. -16 plus 20x minus 8y equals 0. And 36 equals -18y minus 22x. Alright? Well, what I want to do first is I'm going to rewrite this so all my variables are on one side and my numbers on the other. So I'm going to bring all the variables to the right-hand side to match the bottom equation. So the top, I'm going to leave as -16, but then I subtract the 20x and add an 8y to both sides. So we have equals a positive 8y minus 20x here. And then I'm going to bring over the bottom equation. 36 equals -18y minus 22x. So this one's going to be tricky. We have our two equations here, and we need to find a way to eliminate one of the variables. I find the easiest one here to be the y's. If I multiply -18 times 4, I get 72, and 8 times 9 is 72. So I'm going to take the top equation and multiply it by 9, and the bottom equation, multiply it by 4. Now we're going to get some large numbers here, okay, but sometimes that just happens. All right, 9 times -16, which I don't know off the top of my head. 9 times -16 is a -144. And that's equal to 9 times 8y, which is 72y, minus 9 times 20 is 180x, right? So we -180x. Now we distribute the 4. 4 times 36, I think that's, 144. So we have positive 144 here. And that's equal to 4 times -18y, which is a -72y. Okay, let's just double check that. 4 times 18 is 72. Great. And 4 times -22 is a -88. Bring over the x. So now we have to add our two equations here. Okay, and this is a little tricky here. Be careful. We have a -144 plus a positive 144 is we have a 0. Okay, 0 right there. 72y minus 72y is just 0. Okay, -180x minus 188x is going to be a minus 268x. So from there, we don't really care about this 0, so 0 equals a -268x. I divide by -268 to both sides, right? And 0 divided by -268 is just 0. So 0 here is x, or we wrote it first, x is just 0. So now we want to plug that back into another equation to simplify or solve for our y. So it really doesn't matter which equation we choose as far as e's. Let's go with, let's say the second one, let's write down there. We have 36 equal to -18y minus 22x. I'm going to plug 0 in for x there. 36 equals -18y minus 22 times 0. Anything times 0 is just 0, so we're done with that. 36 equals -18y. Divide by -18 to both sides. And that gives me my y value by itself there on the right, and 36 divided by -18 is a -2. So we have y to be -2, x to be 0. Our coordinate point here is 0, -2. And there we have our final answer. -5/7 minus 11/7 x equals -y. And the second equation is 2y equals 7 plus 5x. Okay. Well, I'm going to do this in a few parts here. First thing is, I personally don't like to have fractions with these. So I'm going to take the top equation and just multiply it all by 7. And in doing so, what that causes, we'll multiply all that by 7. It will eliminate the denominator, the idea of a fraction here. So 7 cancel out this 7, so we have a -5. And then minus 11x, 7 will cancel out with the denominator 7, so 11x, which makes it nice. And then 7 times a -y is a -7y. I'm just going to bring across the, well, The bottom one, I'm going to bring across the 2y equals 7 plus 5x. So now what I want to do is I'm going to rearrange this to have all my numbers on the right-hand side and my letters, let's say, on the left-hand side. So my variables. So let's go rewrite that. I'm going to add a 7y to both sides and subtract or add a 5 to both sides. So I have 7y here minus 11x equals, I'm going to add a 5 to both sides, positive 5. Okay. The second equation, the 2y just stays down here, but what I'm going to do is just subtract a 5x to both sides with minus 5x right there. And that's just equal to my 7. So now I want to try to eliminate one of my variables. And to do that, well, I see the 7y and the 2y. If I multiply both of these by a number, I can get something that eliminates. So the top equation, if I multiply that by 2, right? And let's go, 2. Let's go with 2 there. And this one, the bottom one, by negative 7. 2 times 7 is 14, and negative 7 times 2 is negative 14. That should eliminate the y variables. So, and in doing that, I'm going to rewrite that down here. So it's we arrow down because I think I'm going to get out of space there on the side here. So we have a 14y, 2 times 7y is 14, minus 2 times 11 is 22x, equals 2 times 5, which is 10. And I chose the second one to be negative because I wanted one to be positive, one to be negative, so when I add them together, they get eliminated. Negative 7 times 2y is a negative 14y, and negative 7 times a negative 5x is a positive 35x. Negative 7 times a positive 7 is a negative 49. So when I add these two together, okay, the y's will eliminate, okay, they will eliminate, and I'm sorry the camera's shaking at this moment. My lovely cat is rubbing its head against the tripod there. Anyway, negative 14y minus 14y is 0, right there, and then we have a negative 22x plus 35x to come out to be, off the top of my head, that's a 13. So a positive 13 right here, x equals, and then we have a 10 minus 49, plus a negative 49 is a negative 39. Okay. Well, we divide both sides by 13 to get x by itself, and x equals, well, negative 39 divided by 13 is a negative 3. So we have x equal to a negative 3 here. We need to find the y. So let's go grab our second equation. That looks like the easier one, because although fractions are great and all, I prefer not to deal with them if I don't have to. 2y equals 7 plus 5 times x. I'm going to bring this x equals 3, a negative 3, and plug in for that x there. 2y equals 7 plus 5 times a negative 3, and 2y equals 7 plus 5 times a negative 3 is a negative 15. Okay, well, what we can do now here, keep going. 7 plus a negative 15, okay, 7 plus a negative 15 there is a, that's going to be an 8, negative 8, so we have 2y equals a negative 8. I'm going to divide by 2 to both sides, which leaves me with y by itself equals to negative 8 divided by 2 is a negative 4. So we have y to be negative 4, x to be negative 3. We can combine that together to have a coordinate point of negative 3, comma, negative 4. And there we have our final answer. Write a system of equations with the solution, the solution, for negative 3. So our x value is 4, and our y value is negative 3. So we're given the answer, and we need to come up with a system of equations that has that as a solution. Now, there's going to be, clarify here, many answers. There's many system of equations that have that as a solution, okay? So if one that you come up isn't this one, doesn't mean yours is incorrect, okay? So let's go try this. So the way I go about this, I'm looking at this, okay, well, 4 minus 4 and a negative 3. Well, a simple system of equation just has x plus y, right? X plus y, and that's going to equal some number, okay? Well, what if I just put 4 in for x? Okay. and y to be -3, the two values we have here. What does that equal? Well, 4 plus -3 is a -1, right? So if I have x plus y to be -1, I know that if I put in 4 for x and y for y to be -3, that is a possible solution for this first equation. So we have one of them down. That's actually pretty easy to do. The second one's a little trickier. Now I'm going to build upon this. I said, okay, what if we just put a 2 in front of the x? So if we have 2x plus y, what does that equal? Well, 2, again, we want to make sure it works for this though, right? There's many values we can put, we want to make sure it works for 4 and -3. So 2 times my x, which is a 4 here, let's go quote the whole equation here, plus y to be a -3. What does that equal? Well, 2 times 4, right? 2 times 4 is 8, so we have 8 plus a -3 here, which is 5, right? So we have positive 5 equals 5, we can put 5 the whole way. So our equation here, quotes were a little far there, our whole equation, if I set this equal to 5, right, second equation here, I know if I put 4 and -3 in there, I will get a solution, okay? So 2x plus y, if I put equals 5, if I plug in 4 and -3, that is a possible solution to this equation. So now we have two equations that both have a possible solution at 4 and -3 for the x and y values. So that's a possible solution. My answer here, my two equations would be just x plus y equals -1 and 2x plus y equals 5. When my advice for doing problems like this is keep it simple. Start from the beginning, start with something easy, all right? Solution, x plus y, easy. Don't even make it minus x minus y or whatever. Don't try to be fancy with this. The goal is to get it correct, and the goal is to understand the type of problem, not to necessarily find the hardest way possible to solve this problem, okay? So start easy, x plus y, test it out, okay, that equals -1. So if I put x plus y equals -1, when I plug these back in, it'll be a solution. Same thing here. Just put a 2 in front of the x. Multiply by 2 is pretty easy. Okay, so we just did that and see what happened. We tried it out. 2 times 4 plus -3 came up to 5. So we put 5 there, and then 4 and -3 would be a solution right there for this second equation. So since it's a solution for the first one and a solution for the second equation, I can write it here and it's a solution for both of them. So again, our final answer, our two equations here for this system of equations which have a solution of 4, -3 is x plus y equals -1 and 2x plus y equals 5. And again, this is one of many.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.